This is the summative assessment review for Chapter 2. For problem 1, x plus 3 equals negative x minus 5. We want to get the x to the side that has a greater value. And the greater value is the left side. So we're going to add x to both sides. This created a zero pair. X plus x equals 2x. Still don't have x by itself, so we're going to subtract 3 because the inverse of addition is subtraction. Creates a zero pair. Here we have a negative and a negative. So you have 5 negatives and 3 negatives. You're going to add them together. You keep the sign that you have more of, which is a negative. And 5 plus 3 is 8. 2 multiplied by x, inverse property of multiplication is division. Divide by 2 because it creates a giant 1. 1 multiplied by x is x. And now we have negative 8 divided by 2. A negative divided by a positive is going to be a negative, so negative 4. Since x equals negative 4, there's one solution. That means that only negative 4, when plugged back into the equation, will make this equation true. Problem 2, we're going to subtract 2x from both sides. And this creates a zero pair. This creates a zero pair. And now we're left with 1 equals negative 3. Well, that's not a true statement. 1 does not equal negative 3. So there's no solution. There's no value for x that I could put in to make this equation true. For number 3, first we can simplify the left side of the equation and the right side by combining like terms. So we have 3 minus 2, which equals 1, and then the two x variables, 2x plus 1x equals 3x. Now we're going to move to the variable to one side, and we're going to subtract 3x from both sides. 0 pair, and we're left with 1 equals 1. Well, that's a true statement, and that means that there's infinite solutions. When you have the left side, you have the same term or terms on the left side as you do the right side. That means that it doesn't matter which number you put in for x, it will always be true. If you put, if x equaled 10, 3 times 10 is 30, plus 1 is 31. 3 times 10 is 30, plus 1 is 31. So always equal each other. Problem number 4. First I'm going to distribute the 5 to on both sides. So 5 multiplied by 2 is 10. And don't forget that you have to distribute to each term inside the parentheses. So 5 multiplied by x is 5x. 5 multiplied by x is 5x. 5 multiplied by negative 1 is negative 5. Now I can combine like terms. The left side can't combine like terms, but the right side we have these two integers. Negative 5 plus 3 equals negative 2. And now I'm going to move the variable to one side. So I'm going to subtract 5x from both sides. This created a zero pair, and I'm left with 10 equals negative 2. Well, that's not a true statement. So there's no solution. There's no value I can put in for x that will make this equation true. For number 5, I need to simplify the right side by distributing this 2. So I have 2 multiplied by x is 2x, and then I have to distribute to the second term. 2 multiplied by 3 is positive 6. Now I need to get the variable to one side. The right side has a greater value, so I'm going to move the x to the right side. Inverse property of subtraction is addition. 0 pair, 2x plus x is 3x. Still don't have x by itself. I need to get rid of the positive 6 to the other side. So inverse of addition is subtraction. So subtract 6, created a 0 pair. 15 minus 6 equals 9. Now I have 3x on the right side, which is multiplication. 3 multiplied by x. inverse of multiplication is division. I divide by 3 because that creates a giant 1. What you do to one side, you do to the other. 9 divided by 3 is 3. 1 multiplied by x is x. So x equals 3. So this equation has one solution. For number 6, I need to distribute the 5 and the 2 to each term inside the parentheses. So I have 5 multiplied by r, which is 5r. 5 multiplied by negative 1 is negative 5. 2 multiplied by r is 2r. 2 multiplied by negative 4 is negative 8. Now I can simplify the right side by combining like terms. The left side doesn't have any like terms, but the right side I have 2r and 3r, which equals 5r. And negative 8 and negative 6, if the signs are the same, you add them and you keep the sign that you have more of. Well, they're both negative, so it's going to be negative. 8 plus 6 is 14, so negative 14. Now I'm going to go ahead and get the variable to one side, so I'm going to subtract 5r from both sides. 0 pair, and I'm left with negative 5 equals negative 14. Well, that's not a true statement, so there's no solution. For number 7, I need to simplify the expression. And one way I can do this is by expanding each of the terms. So 6x to the 6th power, exponent's just repeated multiplication, so it's x multiplied by itself 6 times. And then x to the 5th is x multiplied by itself 5 times. X squared multiplied by itself 2 times. And then I could cancel these out by creating giant ones, because 1 multiplied by anything is itself. So 1 multiplied by 1 is 1. So these can be canceled out. And then I'm left with 4x's multiplied by itself and 5x's. And then I put 1s as placeholders for the exponents. Anything to the first power is itself. And when you're multiplying exponents with the same base, you add the exponent. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have x to the 9th. So that's one way of doing it. But it's better to know the rule. Well, it helps to know the rule. This is expanding it and simplifying it. But the rule is, when you have exponents with the same base, you add the exponents. So we have 6 plus 5. Well, that's what we were doing here. We had 6 and 5, so we had a total of 11 x's. And then on the bottom, x squared. And then to simplify that, when you're dividing exponents, the rule is you subtract the exponents. So we have x to the 11th minus, I use that fraction bar to remind me it's subtracting, minus 2. And that's what we were doing here. We have 11 x's, and we're subtracting 2 by creating giant ones. 11 minus 2 is x to the 9th. For number 8, I have c to the 3rd multiplied by c to the 10th. So we're multiplying exponents with the same base, so we're adding the exponents. We have 3c's and multiplied by itself and 10c's multiplied by itself. Now we have 13 minus 4, which equals c to the 9th. For number 9, we have z to the 8th multiplied by z divided by z to the 2nd power is z squared. So for z, I put a placeholder of the exponent 1 because anything to the first power is itself. And the rule is multiplying exponents with the same base, you add the exponents. So we have 8 plus 1. And now we have 8 plus 1 is 9, so we have z to the 9th. And now dividing exponents with the same base, you subtract the exponents. So 9 minus 2, which equals z to the 7th. For number 10, I'm going to first explain the rule for the exponent of 0. So if I have 3 to the third power, 3 times 3 is 9 times 3 is 27, and then 3 squared, 3 times 3 is 9, and then 3 to the first, which equals 3, you can see a pattern developing. Each time I decrease the exponent by 1, essentially what I'm doing is dividing by 3. 27 divided by 3 is 9. 9 divided by 3 is 3. So if I follow that pattern, 3 divided by 3 would equal 1. So 3 to the 0 power is 1. And that will work for any value. So anything to the 0 power is going to be 1. And I can continue this pattern for 3 to the negative first. Well, 1 divided by 3 is negative 3. For number 10, I have 3x multiplied by x fifth to the 0 power. Well, that's 0 exponent applies to everything inside the parentheses. So x to the fifth to the 0 power, and again, anything to the 0 power is going to equal 1. And then we have 3x multiplied by 1 equals 3x. Problem 11, we have y to the third power squared. Well, y to the third power squared is 3 multiplied by 2. And you have a power raised to a power, you're multiplying. So 3 times 2 is 6. And now we can simplify it by combining like terms, where we're multiplying y to the first multiplied by y to the 6. Multiplying exponents, the same base, you add the exponents, so 1 plus 6 is 7, so 2y to the 7th power. Number 12, power raised to a power. We're going to go ahead and multiply 2 to the third power, so that's 2 multiplied by 3. 2 multiplied by 3 is 6, so we have z to the 6th power. And now we can simplify multiplying the exponents with the same base. So 1 plus 6 is 7, so 4z to the 7th power. Number 13, let x equal 7, find f of x. So we have f of x equals 3x plus 4. So we're going to plug in the value of 7 for x. So now we have 3 multiplied by 7. 3 multiplied by 7 is 21. 21 plus 4 is 25. So f of x equals 25. Number 14, let x equal 6, find f of x. So if x equals 6, we have 6 squared. 6 squared is 36. 36 plus 3 is 39. So f of x equals 39. Problem 15, we're going to solve for x when f of x equals 8. So this time you have to pay attention. We're not solving for f of x. We have f of x. We want to solve for x. So if f of x equals 2x minus 4, we're not plugging 8 into x. We don't know what x equals, but we do know that f of x equals 8. So we have 8 equals 2x minus 4. So 8 equals 2x minus 4. Now we're going to solve for x. Add 4 to both sides, created a 0 pair. 8 plus 4 is 12. Inverse property of multiplication is division. Create the giant 1. So divide both sides by 2. 1 multiplied by x is x. 12 divided by 2 is 6. So x equals 6. Problem 16, solve for x when f of x equals 15. So we know the value of f of x. It equals 15, and we're solving for x. So f of x equals 15. Now we want to get x by itself. Inverse property of subtraction is addition. 0 pair. 15 plus 3 is 18. Inverse property of multiplication is division, so we're going to divide both sides by 3. Created a giant 1. Now 18 divided by 3 is 6. So x equals 6.